Unconstrained AI is chaotic. The Protégée system captures that energy into a multi-agentic framework designed specifically for automated assessment debriefing and ethical coaching. Deploying a raw large language model is an operational risk. When a system interacts with active coaching clients about personal development and sensitive mental health topics, unpredictability is unacceptable. Coach Ruth Pierce's methodology establishes strict business requirements for this tool. The system requires active human-in-the-loop oversight. It must generate trigger-based alerts, and it must maintain zero hallucinations. Prompt engineering cannot solve this. A complex set of instructions fed into a raw model will degrade over a long session, eventually causing the system to breach its ethical boundaries. The structural solution requires stepping away from a single prompt interface and constructing a decoupled, multi-layered cloud microservices architecture. To build a reliable AI assistant, the underlying infrastructure must enforce strict physical boundaries between application logic, grounded data, user identity, and system observability. We are going to build the Protégée system layer by layer using Azure Cloud Primitives to see exactly how these boundaries function in production. Ethical AI is an architectural constraint that dictates the design of the entire infrastructure stack. This diagram shows the application layer as a central block. This is the execution core, where the multi-agent workflow engine actually lives. To host these core microservices, we use Azure Container Apps. This provides a serverless environment for the application code. Inside this environment, responsibilities are strictly divided. First, we have the Chainlet UI, dedicated entirely to rendering the user interface and managing the chat experience. Right next to it is the Fast API backend. This is the workhorse. It manages the actual session state, executes the prompts, and runs the complex reflection cycles required for multi-agent logic. Managing rapid service-to-service calls in the middle of a timed coaching session requires absolute stability. To guarantee that stability, we layered Dapper into the container environment as an orchestration tool. Dapper manages the pub-sub messaging and state management, ensuring secure, asynchronous communication between the interface and the backend logic. This isolates the workflow engine. The AI executes its prompts without relying on exposed external dependencies. The application layer can execute complex reasoning, but cannot function safely without an isolated memory source. The system operates under the constraint of grounded data. It must perfectly mirror a specific coaching tone and framework without inventing facts. To achieve this, we introduce the data and secrets layer directly below the application engine. The primary storage mechanism here is an Azure database for PostgreSQL flexible server. PostgreSQL natively supports vector storage. This enables the retrieval augmented generation pipeline to feed approved coaching material straight into the Fast API backend. Storing database connections and API keys within the application logic creates a massive security vulnerability. Azure Key Vault sits in this lower layer to securely inject secrets and connection strings upward into the containerized apps, keeping them out of the source code. Decoupling grounded data and secrets into their own layer ensures the AI remains contextually confined to approved methodologies. The system enforces a strict vetting requirement. Only actively engaged clients can access the Protégée environment. To enforce this, we place the front-end and identity layer on top of the stack. Azure Static Web Apps hosts the landing pages and the administrative user interfaces. Basic authentication is insufficient for confidential client data. Entra External ID serves as the strict gatekeeper, blocking unverified access to the application layer. Before any AI logic is triggered, the Microsoft Authentication Library in the browser integrates with the static web app auth provider to verify the user. Microsoft Graph handles group resolution, confirming the client's exact coaching relationship status and assigning the correct permissions. This architecture allows for secure Stripe payment integration, tracking session history to support various pricing models. The identity layer protects the integrity of the coaching experience while turning an AI framework into a sustainable business model. There is one final ethical requirement. The human coach must be notified of sensitive topics without manually reading every chat transcript. We wrap the entire architecture in an observability and DevOps pillar. Application Insights captures real-time telemetry from both the Chainlet UI and the Fast AI backend. That telemetry flows downward into a log analytics workspace, which centralizes all long-term session logs. This centralized pipeline is the engine for trigger-based alerts. Mentions of predefined topics are automatically flagged for human-in-the-loop escalation. The system relies on iterative pilot feedback to update its tone and session flow over time. Azure Container Registry provides the secure storage location for these updated microservice images. GitHub Actions or Azure DevOps pipelines automate the CI/CD process, pushing user-driven improvements directly into the application layer. Observability and DevOps provide the mechanical guarantee of safety. They ensure the AI remains supervised, accountable, and adaptable. The raw LLM has been entirely replaced by a highly regulated, decoupled cloud stack. Separating identity, logic, data, and observability creates a singular, resilient platform. This exact architecture is the only way to satisfy strict human-in-the-loop and RAG-grounded coaching constraints. Because the architecture is hardened, it can be licensed and white-labeled to other professionals without compromising core safety. For organizations, an ethically verified, observable stack acts as a blueprint for enterprise deployment and serious risk mitigation. This framework scales cleanly, smoothly integrating into larger marketplace ecosystems like Microsoft Copilot. By treating ethical constraints as rigorous engineering requirements, cloud architects can build secure, scalable, and highly profitable enterprise solutions.